Hi, my name is Thomas Edwards. I'm a Senior Manager of Solutions Architecture at Amazon Web Services. This demonstration is about MXL, Multi-Vendor Live Media Interoperations. Take a good look at that screen. Every single video feed you see is crossing a vendor boundary, right now, live, on AWS in the cloud. 11 companies, all exchanging ultra-low latency, uncompressed live media with each other using the same open source code. No proprietary glue, no custom adapters, just shared memory and direct memory access over the network. That's the media exchange layer, MXL. And what you're seeing has never been possible before at this scale, at this speed, or with this many vendors working together. The media industry landscape has become more unpredictable. You're planning next year's production budget, and you ask three basic questions. How much content will you produce? And what will the mix look like? And which vendors will you be working with? Think about a broadcaster running the Olympics. 400 channels at peak. 3 weeks later, 40 channels. With fixed hardware, you buy for the peak and pay for it all year long. That model made sense in a predictable world, but it's simply not sustainable when your workflow changes quarterly. In 2023, the European Broadcasting Union, an alliance of 113 public service broadcasters across 56 countries, launched the Dynamic Media Facility Initiative, containerized, software-defined media functions that run on commercially available off-the-shelf hardware, either on-premises or on the cloud. And these functions spin up exactly when you need them, then spin back down. But that vision had a critical missing piece. How do software media functions from different vendors actually exchange live, uncompressed video? Writing a specification like SMPTE ST2110 takes years before vendors achieve interoperability, but you cannot wait years. So, in November 2024, the EBU gathered users and 7 competing vendors in Geneva. The users told the vendors what they needed. The vendors agreed to build a common solution together. Their answer was the media exchange layer, a common, open-source SDK that any vendor can use in their application. Because all vendors use the same MXL code, not a text specification, interoperability arrived in months, not years. MXL was designed to allow software media functions to exchange live media in the most efficient ways. When functions are on the same host, they share memory in a TempFS RAM file system. When functions are on different hosts, MXL flows are exchanged using Remote Direct Memory Access, RDMA, which uses the network interface cards to move blocks of memory over the network without the use of the CPU. MXL also moves media asynchronously. While every media element is time-stamped, it can be moved between media functions as soon as it's ready, in some cases enabling faster than real-time workflows. This MXL interoperability demo runs on 3 EC2 instances in AWS. 2 C6IN instances with 200 gigabits per second of network bandwidth each are the host for multiple vendor containers. 1 G6 instance, equipped with an NVIDIA L4 Tensor Core GPU and 50 gigabits per second of network bandwidth, runs the Grass Valley AMP application. All 3 instances are connected with the Elastic Fabric Adapter, EFA, which provides RDMA for the cloud. A replicator function moves MXL media flows between instances using the EFA. To show how media can move in and out of the cloud, some of the containers receive external compressed media flows from AWS Elemental Media Connect via SRT and NDI. Others read and write to a time-addressable media store, TAMS, for fast turnaround workflows. TVU Networks container exchanges compressed media flows with the TVU Networks account via their media mesh. At the Operations Center, low-latency WebRTC shows the multi-viewers in the demo. 11 organizations are running live in this demo: Appear, Matrox Video, Grass Valley, Riedel Communications, Ross Video, Sony Nevion, TechX, Tag Video Systems, TVU Networks, 3A Design, as well as our customer CBC Radio Canada, who adapted FFmpeg to use MXL. MXL version 1.0 was posted on GitHub 2 months ago. 11 organizations are running live media with it today in this demo. MXL is production-ready, open source, and available to any vendor who wants to add it right now. MXL will be the glue that holds together the dynamic media facility.